in order to make process to process communication possible, we need to make a host to host communication, or that is also called as end to end communication, and that is provided by network layer. So the first and foremost important functionality of network layer is to provide host to host packet delivery. This is the first and foremost important responsibility of the network layer. Second, how to do it? If I want to send a packet from this machine to this machine, what is that information which facilitated to do that? Can anybody remember, or anybody knows? By using what information we can able to identify a machine uniquely so that I can able to communicate? Which information? No.
Address.
Which information?
IP address.
Yes. Which information in the network is going to uniquely identify a machine? So that is the IP address. So that's why. So next is, in order to make this host to host packet delivery possible, we need to have a IP addressing functionality supported by IP addressing. So that means IP addressing is also supported by this particular layer, so that host to host packet delivery can be possible. Okay, now in order to make the communication, let's say this machine has an IP address. So let's say 10.1.1.1. This machine has an IP address, let's say 192.168.1.1. let's say, for example. Okay, so by using this IP address, I can able to make the communication possible. This is the source IP address and this is the destination IP address. Fine. But whenever it is going to go, so my packet has to go from here to here, then it may follow this path to reach here, or it may follow this path to reach here, or it may follow this path to reach here. That means, so going to the final destination, there are multiple paths available in the network, so to reach at the final destination. But at a particular point of time, one has to be decided, one has to be selected. So that's why somebody will do that selection. So that's why, so that functionality to be supported, so by is called as a routing of packets. So now another functionality is to be supported by, so this particular layer, that is routing of packets. That means which route the packets will follow at a particular point of time, that has to be decided, because multiple paths may be available to going to a particular destination. So we have to find, we have to go and decide a particular path for that particular communication. So that is what is called routing of the packets. So deciding the path of the packet to be followed for a particular destination. So that is called as the routing of packet. That is also another important functionality to be provided by this particular network layer. Okay. So then service transport layer provide both the service. Depending on the requirement of the application, it can decide to choose whether to use UDP or TCP. But now if I look into network layer, remember, network layer is connectionless. It is not connection oriented. Network layer is connectionless. But it is connectionless for the network layer of TCP/IP stack. There are other protocols as well as available. Okay, so what is the protocol that works in the network layer of TCP/IP? If anybody remembers, what is the protocol who works in the network layer of TCP? Network layer is not connectionless. So, but network layer of the TCP/IP stack is connectionless. There are some network layer protocols who are also connection oriented. But as far as our TCP/IP stack is concerned, so whatever network layer we are using, that is the IP protocol, it is always connectionless. Try to understand in that way. So IP protocol, so that is working in the network layer of TCP/IP stack, so that is connectionless in nature. So that means, so it does not, if it is connectionless, it does not provide any guarantee whether the packet will be delivered or not. Then what kind of services provide? It is saying that it provides a connectionless best effort service. Why I'm saying like this, best effort service? It provides a connectionless best effort service. What does it mean? Let me give you a raw example. Okay, so let's say I'll provide you a task. I'll give a task. So please carry out the task. That task is very complex. Very complex tasks I'm going to provide you to carry out. If I'd ask you, so can you be able to do it? What should be your answer? What should be your answer? Now what I'm saying, it is connectionless. So there is no guarantee packet can be delivered. Let's try to understand. So now, source is sending a packet. It is coming to this router. Router 1. This is router 2. This is router 3. This is router 4. Okay. Now, first the packet has come from router 1, sorry, source to router 1. So from router 1, the packet is now going to router 2. So what happens? Suddenly at the router 2, the packet is discarded due to certain reason. Forget about what is the reason at this moment. Due to certain reason, the packet cannot be delivered to the destination. Rather, it is discarded here. Okay. As it is a connection less. So no feedback mechanism has to be provided by IP protocol. IP protocol does not provide any feedback mechanism. So if it is TCP, transport layer protocol, if something is received here, so I could able to know. But if it is IP, so whenever a packet is going, so if the packet is received or not received, that information is not coming back to the source. So then if this particular packet is lost, how my source machine could able to know it? So that means some kind of error reporting mechanism should be there. Okay, so that's why as IP layer protocol or IP protocol is connectionless, so it does not provide any kind of feedback. So to the originator, so if any problem goes on, so that's why another functionality need to be supported by this network layer, that is reporting the error. Whenever this packet is lost, it should report. It should report to the originator. That is, your packet cannot be delivered to the other end because of this reason. So then only, so the source machine can take the corrective measure on top of it and go and send the packet to the other end, so that next time the packet may be delivered successfully. So that's why, so another service needs to be provided to carry out that is called as error reporting. Error reporting. That means whenever an error occurs during the transmission of a packet, as IP layer protocol is a connectionless protocol, so that's why some kind of error reporting mechanism must be supported by this, so that the originator of the packet could be able to know about the error and can take the measure on top of it and can deliver the packet next time, so that it can go and deliver to the other end. So that is another functionality needs to be supported by this. So what? Network layer. Last but not the least. So let's look into another important factor here. Okay. So whenever you are going to send a packet, okay, let me draw the TCP IP stack. Based on that, I will explain the last functionality to be supported. So on the top it is application layer, then transport layer, then the network layer, then the data link layer, and then the top. So what is the message? What is the size of a message application can generate? It can be anything. It can be any size. There is no such restriction from the application layer point of view. Okay, so whenever application layer is going to generate a message or sends a message, he can send a message of any size. But whenever it is going to deliver to the transport layer, what the transport layer is going to do, let's say, application layer gives a packet, very big packet, okay, to the transport layer. What the transport layer will do? Will the transport layer go and send the packet as it is, or based on what the packet has to be divided? We have already understood that concept. Can anybody send any packet of any size? But whenever the packet comes to the transport layer, then transport layer will look into the packet size based on MSS. If the packet size is greater than MSS, what it is going to do? It is going to divide the packet into one MSS. That means if I assume, let's say my assumption is that my MSS is 8,000. My packet is sent 10,000. So application layer generates a packet of 10,000 bytes. Now it gives to the transport layer. So whenever transport layer receives this packet, it cannot go and send the packet as 10,000 bytes, because the MSS that is set at the transport layer is 8,000. So now the packet is going to be divided into this 10,000 bytes is going to be divided into two packets. One is of 8,000 bytes, another is of 2,000 bytes. Okay, so now two fragments. So this is called as segmentation. Right, understood very clearly. पहले थे हम बोले थे क्लास में, so फिर भी now at this point of time try to understood very clearly. So whenever application layer generates a message towards the transport layer, so the size of the message can be any. But whenever transport layer receives this message, then based on the MSS, it is going to do a segmentation. Okay, and based on the segmentation, now it is going to prepare more than one. Maybe it is going to prepare more than one segment and go and send into the network layer. So that means now I'm sending application layer is sending one packet as a part of transport layer MSS. So now it is going to divide into two segments and give it to the network layer. Now two segment it is divided. The one packet is divided into two segments, and both the segments is now given to the network layer. So what the network layer is going to do? Network layer is going to give it to the data link layer. Yes or no? So ये दो पैकेट को network layer को किसको देना है? So data link layer को देना है. But whenever it is going to give it to the data link layer, so remember one more concept here. So in the data link layer, we have already understood a NIC card. Can anybody tell link layer functionality and the physical layer functionality? So that means I can say initially, so NIC card is so works on the data link layer. Okay. So if NIC card is there, NIC card is a physical device, hardware. Okay. So whenever I send a packet, so let's say now one packet is of 8,000 byte, another packet is of 2,000 byte. So again, hardware has a capability to carry. So what is the maximum size of the packet he can carry depends on the hardware capability. That is the NIC card. Because NIC card ultimately going to take your packet from your system and deliver it onto the communication link. So that's why whenever it is going to take it, so let's say whenever the 8,000 packet is going to be delivered to the data link layer, so let's say try to understand NIC card has a capability, so 1500 bytes. Normally Ethernet card जो बोलते हैं ना हम, so Ethernet का so maximum capability to carry a packet is of 1500 bytes. Okay, and that is called as MTU, maximum transmission unit. जैसे हम बोले यहाँ पर MSS in the transport layer, we call it as a MSS based on the maximum segment size. So now our packet is divided into two packets, two segments. Okay, so then those two segments is delivered to the network layer. Now network layer is going to decide whether I am going to deliver the same two or I am going to divide it further. So based on what? Based on MTU. What MTU is telling? MTU is telling what is the maximum permissible datagram size. Try to understand this concept very clearly. What is the maximum permissible datagram size? Okay, so if I say my NIC card, MTU of the NIC card is 1500 bytes, that means the size of the datagram is 1500 bytes. When I say datagram, can anybody remember and tell me what is there in a datagram? What is there within the datagram? Because we call a packet in the network layer as a datagram. We call the packet as a segment in the transport layer. We call the packet as a message in the application layer. We call it as a message here. We call it a segment here. We call it a datagram here. Now, based on that, can anybody remember and tell me what is there within a datagram of a particular packet? Including the transport layer header, including the network layer header, the maximum permissible size of a packet or datagram can be 1500 if MTU of the NIC card is 1500. And that is so by default. By default, the Ethernet card MTU size is 1500 bytes. But मेरा पैकेट का साइज कितना है? अभी आ रहा है ऊपर से 8000 bytes का पैकेट मेरा आ रहा है. So can a 8000 packet be carried by the NIC card? No, na. It can carry maximum 1500 bytes of data. So that's why what is going to happen at this point of time? Again, the packet is going to be divided, na? Okay, 8000. If I say 8000, okay, 8000 will be divided into 1500 each. So maybe 5-6 packet is going to be divided. That concept we will read. But anyway, you understood at this point of time. So the packet needs to be divided again. So to carry by the data link layer, and that is called as fragmentation. Try to understood what is a fragmentation, what is a segmentation. Don't be confused. So this is called as fragmentation. So fragmentation is based on what? MTU, maximum transmission unit. What is maximum transmission unit? Maximum transmission unit says that what can be the maximum size of the datagram my data link layer can carry. That is the NIC card present in the data link layer can carry. So that is called as a fragmentation. So fragmentation based on MTU, where segmentation based on MSS, and segmentation happens in the transport layer, whereas so application layer generates a message towards the transport layer. When the packet reaches at the transport layer, so it may happen because of the MSS restriction, the packets needs to divide it. Like the case I have told, if I'm sending a data of 10,000 bytes, so now my packet is divided into two. So because my MSS is 8,000, so one packet becomes 8,000 byte size, another packet becomes 2,000 byte size. Okay. Then what happens? So now the transport layer prepared two segments out of the original message. So now it is going to deliver to the network layer. Now network layer got these two segments. After the network layer got these two segments, so again it is going to decide, can I go and deliver the segment as it is to the data link layer? So before doing that, it has to look into what is the MTU of the NIC card that is present in the data link layer. So if I say, so now I am sending a packet of 2000, supposed to send a packet of 2000 to the data link layer. So now I find, so MTU size is 1500 bytes. So I can't send the packet as it is. So I need to again divide the packet based on this 1500 bytes. So I need to again divide this packet into 2 packets. So that is 2 datagrams. So then only I can able to deliver the packet to the final destination. So based on the MTU, now I am going to again do a division of the packets of single packet into 2 more packets, and this is called as fragmentation. So fragmentation happens because of what? MTU. Okay, and that so happens at the network layer. So fragmentation happens at the network layer, segmentation happens at the transport layer, and application message is generated by the application layer. This is what is we have to understood. Network layer does the fragmentation of packet. That means fragmentation is nothing but dividing the packet into number of packets so that ultimately it can be physically carried out by the data link layer or the NIC card. So that's why another functionality provided by this particular network is called as a fragmentation. Fragmentation. If I divide the packet, मान के चलिए, so originally मेरा 8 packet था. Now I have divided the packet into 2. So whenever I receive at the other end, so receiver के end में, so whenever I receive, I will receive as 2 packets. When I receive as 2 packets, again I have to combine and form 1 packet, na, out of that. So that's why that is called reassembly. So that's why the functionality that is to be provided by network layer is called as a fragmentation and reassembly. So this is the one of the another important functionality to be supported by the network layer as a part of communication. So these are all the 6 functionality, most important functionality we have discussed right now as an overview of what is supported by the network layer. Everybody understood, or anybody has any doubt on top of it, please ask me. Are you understood?
Yes, sir. Yes, sir.
Okay. So now, let's go for the detail of what is the header, because we have already understood. So when I say network layer, a packet is called as a datagram. A packet is called as a datagram in the network layer. Okay, this is the datagram. And as far as datagram is concerned, so again, it is having a payload and having a header. And from the transport layer to the network layer, then on top of that, network layer is going to add its own header. So payload is plus header is my datagram, and the payload is a segment here. Okay, so now let's look into what is the header here. So as I have already told you, in case of transport layer, in case of TCP, what is the header size? 20 bytes to 60 bytes. Similarly here, so as far as the network layer is concerned, just a minute. How to write it? Yes, somehow. Just a minute. Okay, so now what happens? So the size of the size of the header as far as the datagram is concerned vary from 20 bytes to 60 bytes. Okay, so now based on that, let's try to understand what is the detail of this headers. So that is present in the network layer. What is there in this? So 20 bytes, that is the minimum. So that is the mandatory part is the 20 bytes. What is there in this 20 bytes? Okay. So first we have to look into here. So first one is version, VER version. That is of 4 bits. Whatever number I am presenting, same as TCP transport layer, the way I am presenting, that is bits. Okay. So then H length. header length, again 4 bits. Then the service type, that is 8 bits. Then the total length, so that is 16 bits. Then the next one is identification. 16 bits. Then there are 3 flag bits. 3 bits. Okay, this is 3 bits. Then fragmentation offset. Offset. 13 bits. Then next row. Is a time to live. 8 bits. Then the protocol 8 bits. And then the header checksum. That is 16 bits. So then the source IP address. Then the destination IP address. This is 32 bits. Then the destination IP address, that is also 32 bits. Then finally comes the options and padding. Options and padding. Okay, so let's look into in this respect, so the details of each and every header that is present in this particular network layer. Okay, to start with, first is the version field. What is this version field? Because actually, so right now if I look into, so the IP protocol, that is the network layer, what is the protocol that is working in the network layer, that is IP. So IP has 2 versions. One is called as IPv4.
IPv6.
Yes, IPv6. So which version you are going to use, you have to mention here. Okay, so that is the reason of version field here. Okay, so which is a 4 bits. Okay, so then H length. Already you understood the H length field in case of TCP. Exactly the same thing happens in case of IP as far as H length. If your friend is watching the video at that point of time, that packet should be treated with higher priority. But how it will be decided? So whether your packet will be treated with higher priority, or somebody else's packet is going to provide a higher priority. So that is decided by this field. That means depending on the content of this field, service type field. So now the network is going to decide which packet will be given priority over others to process. So that is why this particular service type field is present, and that is basically to provide the quality of service, that is QoS. Shortly we call as QoS. So in order to provide quality of service, so to specific packet, so this particular service type field is going to help and deliver the packet to the other end. So this is important. So for providing the quality of service, which is not a part of your course. Okay, if time permit, I will go for the detail of it, how it is doing. Okay, so then next is very, very important. So total length. Can anybody tell me? So if the total length is equals to, it is represented in 16 bits. So what can be the highest total length possible? When I say total length, it is total length means length of the datagram. So total length, why the name is total length? Because it is including the headers. Okay, that's why it is saying total length. Total length means length of the datagram. Length of datagram. Can anybody tell me what can be the highest possible length of the datagram if it is represented in 16 bits? Yes.
16.
2 to the power 16 minus 1. That is the highest value, na? So that's why it is 65,535. That means this is the maximum say size of a datagram possible. A datagram ka size cannot be more than this. Okay. So the maximum length of a question may be asked in the examination. Very simple question, but if you understood the concept, you can only answer it. Okay. What can be the maximum possible length of a datagram as far as TCP/IP stack is concerned? Sure. Maximum length of the datagram can be 65,535 bytes. Okay. So now best what is there in a datagram? Network layer header, transport layer header, and the application layer message or data. I'm asking about this length, right? I'm asking maximum application length of the application data. That is the application data is the message. Okay. So I'm asking about what is the maximum possible length of here. So ये total इसका total length क्या है? 65,535. मुझे क्या subtract करना पड़ेगा? So in order to get this from 65,535, I have to subtract network layer header length. In order to get, can anybody tell me in order to get the maximum size? What I have to subtract? The minimum header length? अरे ये सर नो अगर मुझे maximum को पहला पाना है तो minimum header length मुझे subtract 5,507 I think minus 28 हो जाएगा तो 507. So this is the byte. This is the size of the maximum application layer data can be possible if the transport layer protocol is UDP. So now if the transport layer protocol is TCP, so it will be 65,535 minus 20 for network layer header, minus 20 for the transport layer header. So it will be कितना हो रहा है? बोलिए मुझे. Tell me how much it is coming. 65,000. The maximum length of the application data depends on whether the transport layer header is UDP or TCP. The transport layer header is UDP, so it will be 65,575 bytes. If it is TCP, it will be 65,495. So this can be a question in the examination. Okay. Now, so और भी question हो सकता है इसमें से. So somebody can ask, what is the maximum length of a segment in TCP? What is the maximum length of a segment in TCP? What should be your answer? On anything else. So that's why maximum length of the segment in a TCP or UDP is 65,000. So 515. Everybody understood? Now one more concept. So I have to tell because a lot of times students got a confusion here. Just a minute. Okay. So now I already told MSS. MSS is maximum segment size. Maximum segment size. Okay. So if I say, so now application layer generates a data of 5,000 bytes. Application layer generates a data of 5,000 bytes and transport layer adds a header of 20 bytes on top of it. So it becomes 5,020 bytes. That means the segment size becomes 5,020 bytes. Okay. If I say maximum segment size is 5,000, maximum segment size is 5,000. Maximum allowable segment size is 5,000. My application generates 5,000 bytes of data. So then application transport layer headers add 20 bytes of header on top of it. Now at this point of time, can anybody tell me, is there any segmentation going to happen? Yes or no? Confusing because so when I say a maximum segment size, actually maximum segment size doesn't tell what is the maximum size of the segment can be possible inside a particular packet. Rather it is a maximum, even if the name is maximum segment size, but it is actually internal, it is maximum allowable application layer data. That is actually confusing. That's why you try to understand very clearly. Maximum allowable application layer data or application message. Getting my point, what I'm trying to say? So MSS is saying maximum segment size, but actually is internally it is not the maximum segment size. It is the maximum allowable application layer message. So here, if my MSS is 5,000, my application layer message is 5,000, no segmentation is going to happen. Try to understand this. Okay, this is a confusion most of the time student face. So that's why I like to clarify this confusion. Even if the term said is maximum segment size, but actually it is not the maximum segment size, rather it is maximum allowable application message. But if I talk about MTU, what is the MTU? MTU is the maximum transmission unit. Maximum transmission unit. And so it is nothing but the maximum datagram size. Maximum datagram size. These two things you try to understand very clearly. Whenever I say MTU, it is the maximum transmission unit. What is nothing but it is maximum internally. What is this maximum transmission unit? Internally it is maximum datagram size. So MSS is maximum segment size, but internally what is maximum allowable application message size. These two things you understood, so that you can able to understood where there is a need of fragmentation, where there is a need of segmentation. Based on that, you can carry out. In the next class, we'll carry about we'll talk about detail about the fragmentation. But so rest of the headers, let me go further in this particular class. Okay, so next is this row completely dedicated for fragmentation and reassembly. So today we'll leave it. Okay, in tomorrow class we are going to detail about it. Identification field, flag, and fragmentation. These three fields completely is required for doing the fragmentation. Fragmentation in the network layer. So forget about it at this point of time. Next, coming to the next part of it, time to live. So time to live, very important one. Time to live. What is this time to live? Let's look into this diagram and try to explain what is time to live. Time to live is shortly called as TTL. Time to live. Okay, so time to live, actually even the name is, so again the name is confusing bit here. Time to live. So whatever value, let's say I have specified the time to live is 5. So that does not mean it is a time actually. It is the maximum number of hop counts. So the packet can travel. Intermediate hop counts the packet can travel before being delivered to the final destination. Okay, TTL is 5 means, so the packet can travel through maximum 5 intermediate nodes before delivering the packet to the final destination. Okay, so that is what is the meaning of TTL. It is not the time, it is the number of hop count. Number of hop count. Again, it is confusing a bit. Number of hop count. Okay, how many number of intermediate nodes my packet can travel before being delivered to the final destination? That is called TTL. Now the question is, what is the need of it? Okay, why there is a TTL requirement? Let's try to understand. Very, very important. So now let's say I'm supposed to, this source machine supposed to deliver a packet to this destination machine. So now what is happening? Now the packet is going to deliver to this. Now the packet from this router is going to deliver to this router. This router delivers the packet to this router. Sometimes, so due to wrong routing, let's say instead of delivering the packet this router to this destination, it again give it back to this router. Now again this router, so gave it back to this router. Then this router give it back to this router. This router give it back to this router. This router give it back to this router. This router give it back to, like this. That means there forms a loop. Due to some wrong routing decision of the packet, now the packet is looping around in a loop instead of delivering the packet to the final destination. Even if that is a correct packet, if it is going to loop around in this particular network, so then if number of packets is going to loop around in the network, so they may lead to congestion. So that means no packet can be delivered to the final destination and they will lead to congestion. So we need to stop this looping. We need to stop this looping. So how to stop this looping? So by using this TTL value, we can able to stop this looping. What is this TTL value saying? So let's say for example, TTL value is 5. So whenever you start the packet is a TTL value of 5 with a TTL value of 5. Now the packet is delivered to this. Whenever the receiver, the router receives this, what is going to do? It is going to decrement the TTL value by 1. Every time an intermediate node receiving a packet, the TTL value will be decremented by 1. So now it is TTL value is 4. So now it is going to deliver the packet to the next one. So when next router is going to get it, again it is going to decrement the TTL value by 1. So it becomes 3. So then, the router again delivered to this router. So again it is decremented by 1. So TTL value becomes 2. So say when again it is going to deliver to this, so now again the TTL value is decremented, so TTL value becomes 1. So when it is delivered to this router, again it is decremented and the TTL value becomes 0. So once the TTL value becomes 0, even the packet is a valid packet, so the router is no more going to forward to this, rather it is going to discard the packet. So that's why the looping cannot be go around. So looping can be stopped, so thereby delivering some other packets. So discarding, because this is looping around. There is no meaning looping around this packet inside here. So rather better to drop this packet. So that's why in this case, this TTL value helps me to stop this loop, so thereby making the communication feasible or possible in this particular network. That is the reason why this TTL value is going to help us. Okay. So now, next one, protocol. What is the protocol field? Protocol field, if you look into this diagram, so whenever I'm receiving a packet, so first I'm receiving the packet at the physical layer. Physical layer is going to deliver the packet to the network, data link layer. Data link layer is going to deliver the packet to the network layer. Then the network layer is going to deliver the packet to the transport layer. So when network layer is going to deliver the packet to the transport layer, in the transport layer there are two protocols running. One is TCP, one is UDP. Kisko dega? Network layer is going to provide the packet to TCP, or the network layer is going to provide the packet to UDP. How it is going to decide protocol field? So network layer can decide to which transport layer protocol the packet is going to be delivered. That is why this protocol field is going to help us. Now, next is header checksum. So previously, if you remember, in the TCP we call it as a checksum, but here we call it a header checksum. Why it is a header checksum? Why it is a checksum in TCP? Let's try to understand. So in case of TCP or UDP, on what part of my data, so the header is checksum is calculated? Can anybody think of? किसके ऊपर मेरा है जो checksum calculation होता है? So header
plus payload.
Yes, fine, very nice. Header plus payload. That means whenever TCP calculates, so the checksum, it has already calculated the checksum for the header plus payload. That means for the segment. Yes or no? But when you talk about IP, that is a network layer, so it is called as a datagram, and in the datagram there is a segment and there is the header. Okay, already TCP has calculated the checksum for the segment part. So what is left out? For which part? So the checksum needs to be calculated. Header. So that's why IP layer does not calculate the what checksum for the whole datagram. Rather, it calculate the checksum for the header part only. Okay. So this calculate the checksum for the header part only. That's why this is called as a header checksum. Okay. It's not a simple checksum. It is a header checksum because only it is calculating the checksum for the header of a particular IP layer or network layer. It doesn't calculate the rest part of it. So only calculate for the header. That's why it is there. And source IP address is already as I have already mentioned. So this is the IP address. Let's say I want to send a packet from this machine to this machine. So this becomes my source IP address and this becomes my destination IP address, without which my communication cannot happen. So every system is assigned with a unique address that is called as IP address. And so whenever a packet is being sent, whoever is sending, so that IP address becomes the source IP address, and to whomever it is going to send the packet, that IP address becomes the destination IP address. So this is all about destination IP address and source address, and then comes the option and padding. So like the option and padding in case of a transport layer protocol, there's an extra thing. Options are extra. You may not. Okay, if it is required, you can go and include it, you can go and exclude it. Okay, again, so this is not a part of your course, as a part of discussion. If time permits, again, I can go for discussing about some of the option field that is available in the network layer of it. And padding is same as padding in case of transport layer. So what is the need of padding in transport layer? Already we understood discussing the question. Can anybody tell me what is the need of padding? What is the need of padding? What is the need of padding? To make alignment. So because my header length is always a multiple of 4 bytes, but due to the addition of option header, if it does not falls in 4 byte octets alignment, so then there is a need of padding. We need to add some 0 to make it a multiple of 4 bytes. That is the reason there is a padding. Okay, that is same as TCP. This is all about the network layer headers. In the next class, we'll go for discussing about detail about So fragmentation and reassembly, and about this header identification.